Hey, it's Mr. A, and we're going to work on a video that's all about the beginnings of composite volume. So essentially what we're working with here is we're going to use our skills that we learned with the beginning parts of volume, how to find it, what its purpose is, and now we're going to apply those skills to some more complicated shapes, but if we break it down, if we use our hands to cut the shapes and draw on the shapes and write things down, then it's very, very possible. So follow along with me here on your paper. So it says Bethany has a raised garden bed. The diagram shows its measurements. All of the corners are right angles. Why would it want to tell us that all of the corners are right angles? Well, that's because these are rectangular prisms, and in order for something to be rectangular, it has to have all right angles. Moving on, if she fills the bed to the top, what does it mean when we fill something? Yes, volume, right? We're filling up the inside of the space. How many cubic feet? Again, cubic feet meaning three-dimensional. And if something is three-dimensional, that means we need to use our volume formula. So remember a couple of things. We can do volume is the length times the width times the height. Or we can use our other formula of taking the base and multiplying that by the height. But if we look at this shape over here, there's a lot of numbers and it's not just a rectangle, right? It's an L. So how can we use our pencil and use our brain to use these formulas with this very weird shape? Yes, split up the shape. Great idea. So we need to take this shape and split it up to determine the length, width, and height of one side, the length, width, and height of the other side, and then add them together. So for example, in here, we could draw a dotted line and cut this shape back at an angle, showing that this would be one shape, and then this could be a separate shape. Sometimes it helps to have two colors. So can you go ahead and find two coloring supplies and split the shape just like Mr. A did, and just lightly shade in the two different shapes, showing the two different pieces. Good. So hopefully we have that concept first, that we can split this shape up. But that's not the only way we can split it up. Let's take a look down below. Using your same two colors, notice that this time they split it up horizontally. So let's take one of our colors and call this shape A, and let's lightly shade it in. And then let's take our other color, call it shape B, and lightly shade that one in. So now that we have these two shapes, what I like to do is I like to write down and label all of the dimensions that I'm given. So I'm looking for my length, I'm looking for my width, and I'm looking for my height for each shape. Let's start with A. I can see that my length is down here below from left to right is 6 feet. I can see that this shape goes 4 feet back as the width, and this part of her garden bed is 2 feet tall. So I have all the dimensions of shape A. Let's look at shape B. I can see the length this time, part of it is 6, but if you notice, B goes all the way back here, right? So I need to make sure that if I'm cutting my shape this way, that I'm accounting that this is the entire length of the shape. So I have to take this 6 and add this 6 together to get our 12 feet of our length. Do you see where that 12 came from? Did you see what I just did there? I took this 6 and I added it to this 6 because those two pieces are the length together. I'm given the width. Notice how far back it goes. It's 6 feet. And the height is the same for the entire shape, 2 feet. So do you see how Mr. A drew all over the shape? I outlined the edges, and it helps my brain to see, okay, what's the length, what's the width, and what's the height? So now that I have all of the dimensions for both of my shapes, now I can multiply them together to figure out our total volume. So I know that 6 times 4 is 24, and 24 times 2 is 48. And I know on this one, 6 times 2 is 12, and 12 times 12 is 144. Well, what do you think I should do now that I have two separate volumes? How do I find the volume of the entire shape, but I have these two separate volumes? Yes, add them together. Sometimes composite volume can be called additive volume to help us remember that we have to add these two pieces together. So 144 plus 48 would give me a total of 192 units cubed. And in this case, since it's feet, we would call it feet cubed. Well, that's one way we can split it up. Remember what we did in the very beginning when we split it up vertically? Let's see if we can get the same answer by splitting it up vertically. So again, please take your two colors. Let's call this one C, and then take your other color and let's call this one D, since they're different shapes. So let's shade in the shapes so our brains can physically see the two separate pieces. Let's label them C over here and D over here. Let's get a little table ready for our length, our width, and our height. Notice they're probably going to be different numbers this time. So let's start with C. So C, I can see that my length is 6 feet. My width, okay, so here's part of the width. But notice that the shape goes all the way back over here. So I need this 4, but I'm missing another piece of the width. Do you see on D how this is going 6 feet back? That's why they're showing you over here that you have to do 6 plus 4 to get this width of 10, because this is only a small piece of it. So our width is 10. Notice no matter which way we cut our shape, which dimension stayed the same? The height. The height is still 2. No matter which way we cut it, the height does not change. All right, let's look at shape D. I can see this time my length of D, since I cut it vertically, is only 6. I can see my width, which we already figured out, is also 6. And then my height is 2. The height does not change. So now I have my two shapes, and now I need to find the volume of the two separate shapes and see if it's the same answer as before. So I know that 6 times 2 is 12, and 12 times 10 is 120. And I know that 6 times 6 is 36, and I know that 36 times 2 is 72. If I add those together, I get a total of 192, and would you look at that? 192 feet cubed is the same thing that I got up here. So that no matter which way you cut these shapes, you get the same answers, so long as you get the correct dimensions. Notice none of our dimensions were the same. Shape A was 6, 4, and 2. None of the others had 6, 4, and 2. Shape B was 12, 6, and 2. None of the others had 12, 6, and 2. So no matter which way you cut the shape, you have to be careful about which numbers you're using. Sometimes you have to add to find the missing dimensions, and other times you'll have to subtract. So let's take a look at a couple of practice problems here, and then you're going to try it on your own. So number 7, it says the recreation center has an L-shaped pool. One part of the pool is 8 meters deep by 6 meters. The other part of the pool is 12 meters by 6 meters. The whole pool is 4 meters deep. What is the volume? Whoa, that's a lot of stuff. So first of all, I would maybe start off by drawing an L shape. So I've got this part of the pool here. So there's part of my pool. And then I know that there's a smaller part of the pool that's also attached. Mr. A is not the best drawer, but you can see generally the same idea. So we know that one of the parts of the pools is 8 meters by 6 meters, and then the other pool is 12 meters by 6 meters, and both of them have a depth of 4. So notice that I'm given for one part of the pool, let's call it A, I have a length of 8, I have a width of 6, and my height is the same for both because deep or depth is the same thing as height, so there's 4. And my second shape, I have a length of 12, a width of 6. Oops, I'm so sorry. Yes, a width of 6, and then a height of still 4. So now I just have to do a little multiplication to figure it out. Can you tell me first, what is going to be the volume of prism A? Well, I would need to do 8 times 6, which is 48. 48 times 4. Well, 8 times 4 is 32. 4 times 4 is 16, plus 3 is 9. So the width of, or the volume of one of the parts of the pool is 192 meters cubed. Can you tell me the volume of B? Well, if I know that 6 times 4 is 24, I have to do 24 times 12. So I get 48 for the first partial product, 240 for the second. I get 288 meters cubed. Now that I know both of the volumes of these pools, I need to, yes, add them up. Let's do it. So I've got 8 and 2, which is 10. I have a 0 in the ones place. I have 9 plus 9, which is 18. And then I have 2 plus 2, which is 4. So I get 480 meters cubed. Now, I'd like you to go ahead and try this next one. Number 8, all by yourself. I'm not going to explain it in the video, but here's my advice. Grab your two colors and figure out which way you want to split these shapes. Do you want to split them vertically and draw a line like this? If you do so, notice for shape B, you're given the length, you're given the height, but you're missing this piece. For A, you're given the width, but we're missing the height, and since we cut part of this off, we're missing the length. So think carefully about that one. If you wanted to split it horizontally, and we take a line and we draw it this way, we cut off top of it, we could call this one C, and we could call the other one D. Well, notice on this one, I'm still given the length. This length is still 2. But notice I cut part of the height, but I see that this is the height that I need, 4, but I'm still missing that width. For the other shape, letter C, now that it goes all the way across, I have the length, I have the width, but on this one, I'm still missing the height. So you're going to have to find some missing dimensions, try your best, and see what you can come up with. Good luck.